what if the dark matter holding our galaxy together isn't actually a particle at all? Like, what if it's the gravitational ghost of a quantum reality that didn't happen?
It sounds completely like science fiction, I know.
Yeah.
But it's actually grounded in some incredibly rigorous math.
Right. And for you, the listener, I know you come to this deep dive because you love a good paradigm shift. You don't just want to hear what the accepted, comfortable textbooks have been saying for 30 years.
No, you want to know what's happening right now on the bleeding edge of human understanding.
Exactly. And today we are going to deliver a massive one because right now, as of early 2026, there is a fundamental crisis in astrophysics. It has reached an absolute boiling point.
It really has. We are currently living through what historians of science call a paradigm rupture.
A paradigm rupture. I love that term.
Yeah, the standard models that have governed our entire understanding of the cosmos for decades they're failing. They are failing hard against new empirical data.
And the alternative we're exploring today doesn't just tweak the old model. It completely rewrites the relationship between quantum mechanics, gravity, and, well, time itself.
It does.
Yeah.
And the source material we are relying on for this deep dive is a groundbreaking paper titled Architecture de la Potentialidad Nulla.
The Architecture of Null Potentiality, which we'll just be calling APN for short throughout this deep dive.
Right. And it's authored by Alejandro Cariatti Martelloni,
who is an incredibly brilliant theorist. Many of you probably already know him from his YouTube channel, actually, at Jagus XAIOUS.
Yes, he's been meticulously documenting the mathematical frameworks behind these ideas on that channel for years now.
So the mission today is to unpack Martelloni's radical alternative, because he is claiming that dark matter and dark energy aren't mysterious, invisible particles, and they aren't static constants of a vacuum either.
No, he proposes that they are the topological memory of unchosen futures.
Which is, that is just an incredibly dense concept to throw at someone right out of the gate.
It is, yeah. But to understand the cure Martelloni is proposing, we first really need to understand the disease.
Right. Why is the establishment of astrophysics in a state of quiet panic right now?
Exactly. And that requires us to look at the standard model of cosmology, which is widely known as the lambda CDM model.
Right, lambda CDM. And since you, the listener, probably followed the broad strokes of astrophysics, you know that this has been the undisputed king of cosmology for a long, long time.
Oh, absolutely. Decades.
It's the framework that tells us how the universe expanded after the Big Bang, how galaxies formed, what the universe is actually made of.
Right, where lambda stands for the cosmological constant.
Which is how we account for dark energy pushing the universe apart.
Yes, and the CDM stands for cold dark matter, which is the invisible mass pulling galaxies together. It was this really neat, tidy package.
But maybe too tidy?
Well, mathematically speaking, it was incredibly tidy because it relied on static, predictable parameters. The model assumes that the universe operates linearly, It assumes that dark matter is made of cold, slow-moving, collisionless particles that really only interact with regular matter through gravity.
It's drifting around.
Right. And it assumes that dark energy is an inherent, totally unchanging property of the vacuum of space itself. And these assumptions, they work beautifully to explain the universe.
Until our telescopes got better.
Exactly. Until our observational technology caught up and allowed us to look closer.
And the first huge piece of technology that just shattered that tidy package was the James Webb Space Telescope, JWST.
Yes. When JWST launched, the whole point, a major point was supposed to be confirming the lambda CDM model by looking back in time to the very early universe.
Because according to the standard model, the universe was supposed to build itself from the bottom up, right? Mm-hmm. Like dark matter pools together super slowly over hundreds of millions of years.
Right, exactly.
And then its gravity slowly pulls in regular hydrogen gas. And that gas slowly compresses, and eventually, finally, the first stars ignite. It's this incredibly slow, grueling process.
Yes, so we expected JWST to look back to the cosmic dawn, which is about 300 to 400 million years after the Big Bang, and see these tiny, chaotic, just struggling clumps of gas.
But that is not what it saw.
Not even close. Instead, JWST looked at that exact epoch in high redshift ranges like Z equals 13, and it observed things that literally shouldn't exist.
We're talking about the data collected by surveys like JADES and SEERS between 2024 and 2025, right?
Yes. They found fully mature, hyperscaled galaxies, massive structures containing evolved metal-rich stars.
Which is wild.
It is. The sheer mass and organized structure of these galaxies at that specific point in the timeline directly contradicts the entire bottom-up hierarchical formation predicted by cold dark matter.
I remember when those first papers hit, the standard model physicists were just reeling. I mean, to put it in perspective for the listener, it's like walking into a kindergarten classroom and finding a bunch of 40-year-old accountants doing taxes.
That is actually a great analogy.
It completely breaks the timeline because under lambda CDM, gravity is just, it's too weak and too slow to pull that much mass together that fast.
Exactly. And if you look at the metallicity of those galaxies, the presence of elements heavier than just hydrogen and helium, it implies that multiple generations of stars had already lived, burned out, and died in massive supernova explosions.
All within like 300 million years of the Big Bang, which is completely impossible under the standard model.
It forces a mathematical impossibility. The star formation efficiency required to build those galaxies at that redshift is sitting around 3.5%, which just shatters the theoretical limits of gas cooling and gravitational collapse in a standard dark matter halo.
So the model is broken, but historically, when a scientific paradigm hits a wall like this, the immediate reaction of the establishment isn't to just throw out the model, is it?
No, never. The immediate reaction is to try and patch it, to add ad hoc fixes.
The duct tape approach to theoretical physics.
Exactly. And we saw that almost immediately with the JWST data. You had theorists proposing the CCC plus TL model.
Oh, right. Covering coupling constants plus tired light.
Yes. Which essentially argued that the universe wasn't 13.8 billion years old, but was actually 26.7 billion years old.
They just decided to double the age of the entire universe, just to give the slow, sluggish dark matter enough time to build those galaxies.
Which is highly, highly problematic. I mean, while it solves the JWST timeline issue in isolation, it completely destroys the cosmological consensus everywhere else.
Right, because if you double the age of the universe, you invalidate all the highly precise measurements of the cosmic microwave background radiation taken by the Planck satellite.
You ruin the calculations for Big Bang nucleosynthesis. You can't just tweak the timeline without causing massive structural failures in the rest of physics.
It's like pulling a thread on a sweater and the whole thing unravels.
Right. So Alejandro Cariatti Martelloni's paper, APN, correctly identifies that this is not an instrument error. It's not a parameter issue. It is a fundamental structural failure in how we understand gravity's relationship with matter.
And the crazy thing is, the JWST anomaly isn't even the only crisis right now. It's not just the early universe that's breaking the rules. The modern universe, like the space right in our own cosmic backyard, is actively defying the standard model too.
Yes, through something called the Hubble Tension.
Let's break that down, because this is the second major pillar of lambda CDM that is currently collapsing.
So the Hubble Tension fundamentally challenges the lambda part of lambda CDM. Lambda is the cosmological constant, right? It represents the energy density of space itself, which drives the accelerating expansion of the universe.
Right.
If lambda is truly a constant, like the standard model claims, then the rate of cosmic expansion should be a predictable static mathematical curve from the Big Bang all the way to today.
Because if you know the starting speed and you know the constant rate of acceleration, you should be able to calculate exactly how fast the universe is expanding right now.
Exactly. And we have two main ways to measure this expansion. We can measure it from the early universe, looking at the cosmic microwave background, the afterglow of the Big Bang. Using the Planck satellite data, standard model physics calculates that the universe should currently be expanding at a rate of roughly 67 kilometers per second per megaparsec.
Okay, 67. But then we measure it locally, right? We look at the space around us today using standard candles like Cepheid variable stars and type Ia supernovae.
Yeah.
And when we measure the local distance ladder with these ultra-precise modern instruments, we don't get 67. We get an expansion rate of about 73.50, plus or minus 0.81 kilometers per second per megaparsec.
And that discrepancy between 67 and 73.5 is the Hubble tension. Now, to a layperson, that might seem like a really small mathematical gap. But in astrophysics, a gap of that statistical significance is an absolute catastrophe.
It's huge. It means the universe is expanding significantly faster locally today than the static cosmological constant says it should be. The standard model literally cannot explain why the acceleration is ramping up.
Right. So lambda is broken because the expansion isn't constant. And CDM is broken because gravity couldn't build galaxies fast enough.
The standard model is failing on both ends of the cosmic timeline. Now, standard physicists are fiercely debating how to patch these holes, but Martelloni's APN paper suggests that patching them is a fool's errand. You just have to replace the foundation.
Yes.
So if we are throwing out invisible dark matter particles and we're throwing out the cosmological constant, what exactly is the architecture of null potentiality putting in its place?
Well, this is where we transition into the core mechanism of Martelloni's framework. And it requires a complete shift in scale.
Okay, shifting gears.
We have to look away from massive galaxies in deep time and focus on the microscopic foundational layer of reality, quantum mechanics. Specifically, we really need to examine what happens during a quantum wave function collapse.
Okay, let's establish the baseline here for everyone. In quantum mechanics, before a particle is observed or, interacts with its environment, it exists in a state of superposition.
Right.
It exists in multiple probable states simultaneously. The classic, albeit tired example is Schrödinger's cat being simultaneously alive and dead inside the box.
While the cat analogy is a massive macro-scale simplification, the underlying math of the Schrödinger equation dictates that a quantum system actually evolves as a linear combination of all possible states.
Right.
Let's strip it down to a simple photon or electron. It exists in a coherent superposition of state A and state B. When that system undergoes a measurement, or when it thermodynamically interacts with its environment, a process we call decoherence, that superposition breaks.
Well, the wave function collapses.
Exactly. Reality, as we experience it in our four-dimensional spacetime, chooses one definite state. State A materializes.
Right. The probability wave collapses into a single point of reality. But APN asks a question that seems almost philosophical at first, but it has profound physical consequences.
Yes, it asks. If state A becomes real, what happens to state B?
Right. What happens to the energy, the actual mathematical information of the reality that wasn't chosen? Standard physics basically says, well, the probability amplitude just drops to zero. It just vanishes.
Which is a massive thermodynamic problem. Conventional physics treats the unchosen counterfactual history as just a mere mathematical artifact that completely ceases to exist.
But Martelloni builds heavily upon an earlier concept known as the objective reduction model, right? The one pioneered by physicists Lajos Diossi and Roger Penrose.
Yes.
Let's decode objective reduction for a second. Because Penrose argued that the wave function doesn't just collapse because a conscious observer looks at it in a lab. He argued that it collapses because of gravity.
Precisely. In the Diossi-Penrose model, a particle in superposition is actually bending the spacetime around it in two mutually incompatible ways.
Oh, wow.
So state A bends spacetime one way and state B bends it another way. As the mass of the superimposed object increases, the discrepancy between these two spacetime geometries grows. It keeps growing until it reaches a critical gravitational threshold.
The universe essentially cannot sustain the tension of two conflicting geometries.
Exactly. So it forces a collapse, it snaps.
Okay, so gravity forces the snap. But APN takes that snap and introduces holographic conservation principles. And I want to push back on this a bit because holographic conservation sounds like a sci-fi buzzword. What does it actually mean in the context of this unchosen state B?
Well, it refers to the invariance of entanglement entropy. In fundamental theoretical physics, particularly when you're dealing with the holographic principle, information is physical. It has a real thermodynamic weight.
It's not just an abstract concept.
No, not at all. You cannot simply delete information without violating the core tenets of thermodynamics. So when that gravitational snap occurs, the entropy of the unchosen state B cannot undergo an absolute erasure.
The energy of that unchosen state has to go somewhere.
Yes, it must go somewhere.
But it doesn't go into our 3D universe, because if billions of unchosen quantum realities were dumping thermal energy into our universe every second, space would literally be boiling. We'd see that energy in the cosmic microwave background, and we just don't. So where does it go?
It is channeled orthogonally. It is injected out of our observable dimensions entirely.
Whoa.
When the superposition persists, it generates what APN describes as an ambiguity in the spacetime metric. It generates a gravitational self-energy that creates physical shear stress on the fabric of space.
Okay.
When the geometry finally snaps to resolve the superposition, the residual tension from the unchosen state is blasted sideways into the extra compactified dimensions predicted by string theory.
Okay, now we are entering the realm of extra dimensions. And for listeners who might be naturally skeptical of string theory, it's important to note that Martelloni isn't just making up dimensions to hide the math, right?
No, absolutely not. He is specifically utilizing the type IIB supergravity limit of string theory, which mathematically requires the existence of a microscopic internal six-dimensional space known as a Calabi-Yau manifold.
Right. In standard string theory, to make the mathematics of quantum gravity work at all, our universe cannot just be the 3 dimensions of space and 1 of time that we experience every day. There must be 6 additional spatial dimensions.
Yes, but we don't see them because they are compactified. They're curled up into these unimaginably small, incredibly complex geometric structures at every single point in our space. These are the Calabi-Yau manifolds.
Okay, so I want you to picture this. A nuclear fusion reaction happens inside a star. Atoms are constantly interacting, bumping into each other, forcing wave functions to collapse. Trillions of times a second, the universe is snapping into a chosen reality, and the discarded information, the unchosen futures, are being injected directly into these microscopic, 6-dimensional Calabi-Yau geometries.
Exactly.
What happens to that energy once it's inside?
It interacts with the fundamental building blocks of reality within those dimensions. Closed superstrings. When the quantum snap injects this inertial energy, it excites the harmonic oscillators of these microscopic strings.
Okay.
Because the Calabi-Yau manifolds is a compact space filled with complex topological holes or cycles, the excited energy forces these strings to wrap themselves entirely around the geometry of the extra dimensions.
So imagine taking a rubber band and wrapping it through the center hole of a really complex multi-dimensional pretzel. It wraps around and just connects back to itself.
Yes, that's exactly it. In string theory, this creates what we call winding modes. APN dictates that the injected quantum energy forces the strings into a very specific state where the winding number denoted mathematically as W equals 1.
Okay, W equals 1.
Now, here is the crucial mechanism that makes APN work. Due to the strict laws of topological invariance, a string wrapped around a non-contractible cycle in a Calabi-Yau manifold cannot simply slip off or untie itself.
It's stuck.
It's topologically locked in place. The only way it can ever be destroyed is if it collides with a string perfectly wrapped in the exact opposite direction, a W equals -1 string.
But since these injections are happening constantly from fusion and quantum decay, the dimensions are just filling up with these locked strings.
They accumulate. They become an incredibly stable, exceptionally long-lived gas of winding modes trapped in the extra dimensions. They do not interact with the electroweak force. They do not emit or absorb light.
Wait, invisible, long-lived, doesn't interact with light. You're literally describing dark matter.
Yes.
But how does tension on a string in a 10th dimensional pretzel actually affect a galaxy in our 3D universe? Like, if it's trapped completely outside our observable dimensions, how do we feel its gravity?
This requires an understanding of what APN calls the dimensional Mach principle, which is facilitated by a warped metric. In string theory, the dimensions are not entirely isolated from one another. They are connected by a warped geometry, mathematically represented by the warp factor E to the 2a of y.
Okay.
The accumulation of these locked winding strings in the Calabi-Yau dimensions generates real physical inertial tension. They literally have mass.
So they're pulling taut against the geometry of the higher dimensions.
Correct. And that immense tension fundamentally alters the tensor field of the extra dimension. Because the dimensions are coupled, that warping bleeds back through into our macroscopic four-dimensional space-time.
Oh.
Imagine our 3D universe is the surface of a frozen lake, and the extra dimensions are the water deep underneath the ice. If you create a massive permanent pressure current deep under the water, the surface of the ice is going to warp, stress, and bow inward.
So the gravitational pull we attribute to dark matter is actually the macroscopic 3D footprint of this 10D topological tension. We look at a galaxy, we see its stars being held together by this immense invisible gravitational well, and we spent decades assuming it was a cloud of phantom particles.
Right.
But Martelloni is arguing that we are actually feeling the collective gravitational weight of trillions upon trillions of quantum collapses that have permanently scarred the geometry of the higher dimensions. Dark matter is literally the ghost of unchosen realities.
It is a stunning conceptual leap, but it is entirely derived from the strict topological conservation of entanglement entropy. If you accept that information cannot be deleted, it must be stored. APN argues that dark matter is simply the universe's ultimate storage drive for counterfactual quantum histories.
That is profound. It completely flips the script on what the dark sector actually is. But a beautiful mathematical concept is useless if it doesn't solve real observational problems.
Exactly.
So let's take this mechanism that quantum collapse creates dark matter and apply it to the crisis we started with. Let's go back to the JWST anomalies. How does APN solve the existence of massive mature galaxies 300 million years after the Big Bang?
To solve the JWST anomaly, APN introduces what Martelloni calls the causal inversion. As we established earlier, the old lambda CDM model operates from the bottom up. Dark matter pools first, creating a gravitational well. Then, over immense stretches of time, regular baryonic gas falls into that well, heats up, and forms stars.
The dark matter precedes the stars.
Yes.
But JWST proved there simply wasn't enough time in the early universe for cold dark matter to pool and pull in the gas. The clock essentially ran out before the game even started, so APN reverses the arrow of causality.
Exactly. APN posits that in the extremely dense, highly pressurized environment of the early universe, just after the era of recombination, massive clouds of free neutral hydrogen gas were actually able to collapse under their own self-gravity without needing a pre-existing dark matter halo.
Because the universe was just so much denser back then.
Right. This direct collapse ignited the very first generation of stars, which are known as population 3 stars.
Now, population 3 stars are purely theoretical right now, but we know based on physics what they must have been like. They contained absolutely zero heavy metals. They were pure hydrogen and helium.
Yes.
And why does that matter? Because metals act as a cooling mechanism in stellar formation. Without metals to bleed off heat, these early stars couldn't form in small, stable sizes like our sun. They had to be absolute monsters.
They were hypermassive, terribly unstable, and burned at frantic exponential rates.
Yeah.
Their surface temperatures and internal core pressures were magnitudes higher than anything in the modern universe.
Wow.
Now, apply the APN mechanism to a hypermassive nuclear reactor. From a quantum mechanical perspective, what is a star? It is a colossal, continuous engine of environmental decoherence.
Right. Every single microscopic event inside that star, every time an atom fuses, every time a photon scatters off an electron, every time the strong nuclear force interacts, a quantum wave function collapses.
Trillions upon trillions of times every single microsecond. The sheer volume of quantum measurements occurring inside a population 3 star is almost incalculable. And according to APN, every single one of those collapses violently injects the unchosen reality's energy into the local Calabi-Yau manifold,
Locking a new winding string into place.
Exactly.
Oh, this is brilliant. The stars themselves are acting as massive injection engines. They are rapidly, furiously blasting topological tension into the extra dimensions localized right around them.
The causal inversion becomes totally clear. The frantic quantum activity of those first massive stars literally created the dark matter halo around them. They rapidly crystallize the dark matter in the subspace, directly surrounding their physical location.
It's like the flies built the spider web. In the old model, we thought the dark matter web had to be built first to catch the stars. But APN argues the stars ignited first, and their violent, rapid thermonuclear burning literally spawned the gravitational dark matter web around them.
And this solves the JWST timeline perfectly. Because population 3 stars burned so fiercely, their lives were incredibly short, perhaps only a few million years before they went supernova.
But in that short time, they entrenched a massive permanent dark matter halo.
Exactly. So when those first stars exploded, they expelled the first heavy metals into the surrounding space. But the gas and the new metals didn't just drift away, because the newly forged dark matter halo acted as an immense gravitational anchor.
It immediately trapped the expelled material, allowing it to rapidly cool and form the second generation of stars, which are the exact mature metal-rich galaxies JWST is observing right now.
Wow.
So there is no need to double the age of the universe. There's no need for magic parameters. The galaxies formed incredibly fast because the intense quantum fires of the first stars locally generated the gravity needed to hold them together.
Exactly.
That is such an elegant solution, but it brings up a massive point of friction with standard physics, doesn't it? Because if dark matter is created locally by burning stars, it completely changes the physical shape of a dark matter halo.
Yes, you are referencing the small-scale crisis of dark matter.
Exactly.
Yeah.
If you ask a standard model physicist what a dark matter halo looks like based on their supercomputer N-body simulations, they will tell you it's generally smooth.
Right.
Because cold dark matter particles don't interact with regular matter or light, they just kind of slide past each other. They form a relatively continuous, isotropic, fuzzy sphere around a galaxy. The gravity should be smoothly distributed.
The standard model absolutely predicts smooth profiles. But if APN is correct, the topological injections of dark matter happen discretely. They happen precisely adjacent to the 3D source of the nuclear fusion. The rubber bands in the 10th dimension get wrapped up right next to the physical stars.
Meaning the dark matter shouldn't be smooth at all, it should be lumpy. It should map exactly to the historical locations of intense star activity. If a massive cluster of stars burned and died in one specific quadrant of a galaxy, there should be an ultra-dense lump of dark matter permanently anchored in that exact spot, even if the stars are long gone.
And that lumpy, heterogeneous profile is exactly what the latest high-resolution interferometry arrays are proving.
Yes.
Let's look at the observational data published between late 2025 and early 2026 from the ALNO and NOEMA telescope arrays. This data has provided devastating empirical evidence against the smooth gas theory of cold dark matter.
This is the HRST-3 anomaly. I love this piece of the puzzle because it uses gravitational lensing, which is honestly one of the coolest phenomena in astrophysics. Let's explain how this works so we understand why the HRST-3 data is breaking the old models.
Gravitational lensing, which was predicted by Einstein's general relativity, occurs when you have a massive foreground object, like a very dense galaxy situated directly between Earth and a much more distant background galaxy. The immense gravity of the foreground galaxy literally bends the fabric of space-time, acting like a cosmic magnifying glass. As the light from the background galaxy travels toward us, it gets bent around the foreground mass.
And because the light is taking multiple bent paths around the massive object, we don't just see one image of the background galaxy. We see multiple mirrored images of it surrounding the foreground lens.
Specifically, when dealing with a massive lenticular galaxy acting as a lens, the standard geometry of spacetime predicts the creation of 4 distinct mirrored images arranged in a cross shape.
Okay.
This is famously known as an Einstein cross. The HRST-3 system is a prime example of this. You have a massive foreground lens at a redshift of roughly 1.0, bending the light of a violently starbursting background galaxy located at a redshift of 3.0607.
So standard N-body simulations using smooth, cold dark matter predicted HRST-3 would display the classic 4 images. But when the research team, led by Pierre Cox using the LMA array, looked at the higher resolution carbon monoxide emission lines, specifically CO1 to 0 and CO4 to 3, they found something impossible.
They didn't just find 4 images.
Right in the dead geometric center of the cross, they found a massive anomalous 5th image.
And a 5th central image in a lensing system of this specific configuration breaks the standard optics of general relativity when applied to a smooth dark matter halo. For a central image to survive the focal properties of the lens and actually reach our telescopes, there must be an unbelievably acute, impossibly dense concentration of mass exactly at the core of the lens.
I remember reading the breakdown of this. The visible stars in that foreground galaxy don't even come close to accounting for that math.
Not even close.
To make the math work and bend the light enough to create that 5th dot, standard physicists had to mathematically insert a hyperdense core of dark matter, exceeding 1 trillion solar masses packed into a tiny localized point in the center.
Over 1 trillion solar masses in an acutely centralized point. Smooth, collisionless, cold dark matter absolutely cannot clump that tightly. Its inherent kinetic energy actively prevents it from packing into such an extreme localized density without smoothing out over a much larger volume.
It just doesn't work.
No. The researchers were forced to admit that the dark matter in the HERS-3 lens is radically asymmetric, highly heterogeneous, and excessively lumpy. The traditional models entirely fail to explain it without inventing completely novel, complex interactive forces between dark matter particles.
Which is just more duct tape. I would imagine the standard model physicists argue that maybe there's an invisible supermassive black hole there or some other exotic baryonic matter we just can't see.
They certainly attempted to model those scenarios, yes, but the dynamical mass and the specific deflection angle required for the 5th image definitively rule out a central black hole of standard proportions. The mass profile required is distinctively indicative of a localized dark matter spike.
But APN predicts this massive spike perfectly, because in the APN framework, dark matter is the fossil record of quantum collapse.
Precisely. Remember, the foreground galaxy in HERS-3 is an ancient, massive lenticular galaxy. In its deep past, its core was a violent crucible of star formation, hosting generations of massive, short-lived stars.
Right.
Because the quantum entanglements operate as discrete, localized events triggered inside those specific atomic furnaces, the inertial accumulation of winding strings in the extra dimensions happen geographically adjacent to that core.
So that trillion solar mass invisible clump isn't just a random gathering of particles. It is the permanent spatial memory of an ancient, violent era of star formation in that specific spot. We are literally looking at a gravitational ghost.
Gravitational ghost is an incredibly apt description.
The stars that burn there have been dead for billions of years, but the immense quantum footprint they left behind, the topological scarring of the extra dimensions, is still there, heavy enough to bend the light of a galaxy sitting behind it.
The topological remnants obey the deep galactic past of extreme decoherence, stabilizing the local matrix. The localized dark mass is the inescapable sink for the history of the baryonic matter that used to burn there.
Wow.
The ALMA data proves that dark matter is lumpy, and APN provides the exact mathematical mechanism for why that lumpiness mirrors ancient stellar geometry.
Okay, this is genuinely blowing my mind. We have solved why early galaxies formed so incredibly fast, and we've solved why dark matter is locally lumpy rather than smoothly distributed. We've thoroughly explained the inward pull of the universe.
But we're only halfway there.
Exactly, because the universe isn't just pulling together, it is pushing apart. If dark matter is just the ghost of dead stars pulling things inward, what is accelerating the expansion of the universe? How does Martelloni's theory tackle dark energy, and how does it solve the Hubble tension we discussed at the very start?
This is where the true elegance of the APN architecture reveals itself, because it finally unifies the dark sector. To understand dark energy within this framework, we have to transition from looking at localized string tension to looking at the global effect of all these winding strings occupying the Calabi-Yau dimensions across the entire universe.
Right, because earlier we established that these strings are getting injected into the compact extra dimensions, and they're topologically locked. They can't get out.
Exactly. And to explain the macroscopic consequence of this, APN utilizes a well-established string theory mechanism known as the KKLT formalism, named after physicists Kotru, Kalosh, Lind, and Trivedi. In very simple terms, the KKLT formalism explores how you stabilize these extra dimensions so they don't just collapse in on themselves.
Because gravity naturally wants to crush things down.
Yes. But as more and more quantum energy is injected into these dimensions, locking more and more winding strings, designated as W sub I, into place, these strings take up topological volume. They vibrate. They possess localized energy.
Okay.
And when you pack an increasing amount of energized strings into a fixed microscopic compactified geometry, you generate a global thermodynamic pressure.
It's like inflating a tire. You keep pumping air molecules, or in this case, wrapped strings, into a fixed space. They are going to push outward against the walls of that space.
A centrifugal repulsion against the geometric boundaries of the Calabi-Yau space, yes. The strings exert this outward pressure to avoid a topological singularity, to prevent the dimensions from being crushed. And just as the localized inward tension of the strings bleeds through the warped metric to create the gravity of dark matter,
this massive outward pressure also bleeds through.
Exactly. It projects into our four-dimensional macroscopic metric as a massive, universal, expansive push. Martelloni defines this mathematical projection as the uplift potential, or V sub uplift. This uplift potential is what we perceive observationally as dark energy.
It's a cosmic pressure cooker. Every single time a quantum decision is made, every time a star fuses an atom, a tiny bit more steam is pumped into the extra dimensions, which means the pressure isn't constant.
No, it cannot be constant.
In the early universe, just a few 100 million years after the Big Bang, there hadn't been that many quantum collapses yet. The total volume of historical stellar fusion was relatively low, so the pressure in the extra dimensions was low.
Which means the expansive push, the uplift potential, was weaker in the early universe.
But today, the cooker is completely full of steam. We have 13.8 billion years worth of trillions of stars constantly burning, supernovas exploding, and atomic interactions forcing wave functions to collapse. The sheer volume of locked strings in the extra dimensions is enormous, and the outward pressure is immense. The universe is pushing outward faster and faster.
You have just perfectly articulated the APN solution to the Hubble tension. Remember, standard physics insists that dark energy is represented by lambda, a static constant.
Right.
But APN dictates that dark energy cannot be constant. It must be dynamic. It must increase over time as the integral volume of stellar energy injections increases.
Wow.
The Hubble tension, the fact that local modern expansion is faster than the early expansion, is not a measurement error. It is the direct mathematical consequence of a universe accumulating quantum history.
In cosmology, a dynamic, changing dark energy field is called quintessence, right?
Yes. And specifically, APN models a thawing quintessence. The repelling force starts essentially frozen weak and negligible in the early universe, allowing matter to clump and form galaxies without being ripped apart. But as cosmic time progresses and the quantum injections accumulate, the quintessence thaws and grows stronger, driving the accelerated expansion we see locally today.
And just like with the HRSS-3 dark matter data, this isn't just a fun thought experiment. The hardest, most recent empirical data is proving this exact dynamic. Let's talk about the DR2 results that hit in early 2026, because this was an absolute earthquake in the physics community.
The Dark Energy Spectroscopic Instrument, or DSI, is arguably the most powerful tool we have for measuring cosmic expansion. In early 2026, the DSI collaboration released its data release 2.
Okay.
DSI operates by measuring the large-scale clustering of galaxies across the universe. Specifically, it maps baryon acoustic oscillations, which are essentially the frozen spherical sound waves left over from the dense plasma of the early universe.
Right.
These acoustic oscillations act as a cosmic ruler, allowing us to measure how the scale of the universe has changed over billions of years.
And by tracking this cosmic ruler across deep time and combining it with catalogs of supernovae and the cosmic microwave background, they were able to calculate the equation of state for dark energy. The standard model parameter for this is not to be confused with the string winding number we talked about earlier. Standard physics says W must equal exactly -1 and it must never change.
That is not what DSA found. The DILI-SIDR2 results revealed a staggering statistical deviation from the standard lambda CDM model. When mapping the expansion, they found that the dark energy equation of state is not -1.
Right.
Depending on the specific combination of data sets used for cross-verification, such as combining DSI with the Pantheon Plus supernova catalog or the Union 3 dataset, the data show that dark energy deviates from a constant with a statistical confidence ranging from 2.8 sigma up to an astonishing 4.2 sigma.
I really want to pause on that number for our listeners, because in physics, a 3 or 4 sigma result is the fire alarm going off. It means there is only a tiny fraction of a % chance that this is a statistical fluke. A 4.2 sigma deviation means the standard model is almost undeniably broken.
The data clearly extracts evolution parameters, denoted as W sub 0 and W sub A, that trace a curve exactly matching a thawing quintessence. The DASI data definitively proved that the dark energy in the universe was not eternally hostile to structure formation. It was significantly weaker in the past and ramped up notoriously in the late stages of cosmic chronology.
But standard model loyalists tried to argue it was a calibration error with the supernova data, didn't they?
They did, and the debate is certainly still raging in some circles. There are valid criticisms regarding how supernova light curves are standardized across different galactic environments. However, the sheer multi-probe corroboration in the DR2 release makes the evolving dark energy signal incredibly robust. And crucially, Martelloni's APN equations predicted this exact curve. The mathematical framework of APN frames the evolution of this dynamic expansion parameter as an exact match to the integral volume of stellar decoherence over time. The steam pressure in the extra dimensions perfectly aligns with the DSI measurements.
Which brings us to perhaps the most elegant part of this entire theory. We've been treating dark matter and dark energy as two separate things, which is exactly what standard physics does. Standard physics says dark matter is an invisible particle that pulls, and dark energy is a property of vacuum space that pushes. Two completely isolated, unrelated phenomena that just happen to govern 95% of the universe.
And treating them as isolated phenomena creates the most embarrassing, unanswerable question in standard cosmology, the cosmic coincidence problem.
The ratio problem. If you look at the energy density of the universe today, we are told it is roughly 27% dark matter and 68% dark energy. Normal matter, everything we can see, touch, and interact with, is just 5%.
The coincidence lies in the magnitudes. According to lambda CDM, dark matter is a fixed amount of particles created during the Big Bang. As the universe expands, that fixed amount of dark matter gets diluted, so its density drops continuously over time.
Right.
Conversely, dark energy is a static constant of the vacuum. As the universe expands and creates more vacuum, the total amount of dark energy grows exponentially.
So you have two lines on a graph. One is dropping rapidly and the other is climbing exponentially. The fact that right now, at this exact moment in the 13.8 billion year history of the cosmos, those two wildly divergent lines just happen to be within the exact same order of magnitude, 27% and 68%, is an absurd coincidence.
It requires a level of extreme fine-tuning that borders on the unscientific. It's akin to watching two vehicles driving on a highway at vastly different exponential rates of acceleration and deceleration, and yet right at the exact millisecond you decide to look out your window, they happen to be driving perfectly neck and neck.
Right.
To explain this away, theorists have spent decades inventing unknown scalar couplings, phantom energy fields, and complex interacting dark sector models entirely ad hoc, just to justify why we have to live at this specific lucky epoch.
I always hated the fine-tuning argument. It felt like standard physicists were just shrugging and saying, well, isn't it lucky we live exactly at the moment when these two completely unrelated forces happen to balance out? But APN doesn't need to invent anything new to explain this, because Martelloni introduces what he calls the thermodynamic resolution.
The resolution is profoundly simple once you accept the premise. In the architecture of null potentiality, dark matter and dark energy are not two distinct, unrelated entities. They are two phenomenological manifestations of the exact same singular topological mechanism. They're two sides of the same coin.
Let's break this unification down because this is the holy grail of modern cosmology.
We have established that the hyperdimensional injections from quantum wave collapses create topological strings wrapped around the Calabi-Yau dimensions. The presence of these locked strings creates two simultaneous, inextricably linked geometric effects.
Okay.
First, you have the localized elastic tension of the string winding itself. This extreme localized tension is confined deep within highly suppressed microscopic geometric funnels called Klebanov-Strassler throats. This creates a constrained, concentrated gravitational density that warps the local 3D metric,
Which we perceive as dark matter, the localized inward pull holding the galaxy together.
Precisely.
Yeah.
But simultaneously, the collective presence of all these strings across the entire universe creates a global, transverse outward pressure. They are pushing against the compactified space to prevent a total topological collapse. This generates a diffusive radial pressure that expands the global 3D metric.
Which we perceive as dark energy, the universal outward push.
They are an isometric response. You do not need a magical, finely tuned coincidence to explain why their magnitudes are in the same ballpark today. They match because they both originate from the exact same historical volume of entrenched, counterfactual quantum states.
Right.
The progression of the dark energy acceleration is forcibly, mathematically locked to the amount of dark matter mass injected. As more stars burn, more dark matter is injected, which directly generates more outward dark energy pressure.
Let me try a terrestrial analogy here, slightly elevated from earlier. It's like standing in an enclosed room with a massive fireplace. Standard physicists walk into the room, measure the pile of heavy ash sitting in the grate, and then measure the ambient thermal heat pushing outward against the walls of the room. And they say, wow, isn't it an incredible, unbelievable cosmic coincidence that the total mass of this heavy ash perfectly correlates with the exact temperature of the heat in the room? They must be perfectly fine-tuned.
A fantastic illustration of the absurdity of the coincidence problem.
You don't need to invent a complex theory to explain why the ash and the heat match, because they both came from the exact same singular source, the burning log. In the universe's case, the burning log is the continuous history of quantum collapses inside stars. The dark matter is the localized heavy ash left behind in the grate, and the dark energy is the global thermodynamic heat pushing outward against the walls of reality.
It is a profound thermodynamic resolution. Martelloni's framework strips away the need for phantom particles, ad hoc cosmological constants, and magical epochs of fine-tuning. We are simply witnessing the split macroscopic visualization of a single-dimensional sink that responds isometrically to the arrow of quantum time.
Okay, this theory is undeniably elegant. It cleanly solves the impossible early galaxies of JWST through causal inversion. It solves the lumpy mass spikes of LMA's 3 data through localized quantum injections. It solves the Hubble tension and the DSI-DR2 thawing quintessence through dynamic pressure. And it solves the cosmic coincidence problem through thermodynamic unification.
It does.
But we have to be rigorous here. Elegance is not enough in physics. A theory is only as good as its testability. String theory has famously been criticized for decades precisely because it operates at energy scales we can't test. Does Martelloni's APN paper actually provide a falsifiable way to prove this? Or is it just beautiful, untestable philosophy?
That is the most critical question, and it is the exact reason APN is gaining so much traction right now. Chapters 6 and 7 of the paper are dedicated entirely to the mathematical falsifiability of the theory. Martelloni does not hide behind inaccessible energy scales.
Good.
He derives a rigorous, highly specific, and testable metric called the equation of historical inertial coupling.
The equation of historical inertial coupling. What exactly does this equation link together?
It mathematically and inextricably links the historical star formation rate of a given region of space to the topological distribution of its dark matter mass.
So it's an equation that says, if X amount of stellar mass burned here over the last 2 billion years, there must be exactly Y amount of dark matter anchored right here today.
Exactly. We can observationally measure the historical star formation rate of galaxies through various well-understood methods, looking at ultraviolet light, infrared dust emissions, or carbon monoxide spectral lines.
Right.
Martelloni's equation defines a baryonic decoherence index, which calculates the exact rate at which those historical atomic fusions forced wave functions to collapse. It then calculates the transversal thermodynamic efficiency of how that injected energy bleeds through the warped dimensions to create mass. It is a precise, falsifiable integral.
Which means if you map the dark matter profile of a galaxy, APN dictates it cannot be a random, sterile, smooth cloud. It must be the undeniable mathematical mirror image of the total extinct thermonuclear past of that specific region.
It must map 1-to-1. And here is where the timing of Martelloni's paper is incredibly fortunate. Testing this requires mapping dark matter and ancient star formation across massive swaths of the extragalactic universe. That sounds impossible, but we are currently on the precipice of possessing the exact astronomical instrument designed to do precisely this. We are waiting for the launch of the NASA Nancy Grace Roman Space Telescope.
The Roman Telescope. This is NASA's next flagship observatory, currently slated for launch in late 2026 or early 2027. Let's talk about what makes Roman so special compared to Webb or Hubble.
The Roman Space Telescope is armed with a 300.8 megapixel wide-field instrument, or WFI. To understand its power, consider that its field of view is 100 to 200 times wider than the Hubble Space Telescopes, but it maintains the exact same sensitive, high-resolution imaging capabilities in the near-infrared spectrum.
So Hubble gave us exquisite keyhole views of the universe. Roman is going to give us an ultra-high-definition panorama.
Yes, it is the most formidable statistical probe ever designed to constrain the tensor matrices of the cosmos.
And Roman has 2 primary observational surveys planned that are perfectly suited to act as the ultimate judge, jury, and executioner for APN. Let's walk through them. First is the HLTDS.
The High Latitude Time Domain Survey. During this survey, Roman will spend roughly 180 days tracking thousands of Type ES supernovae deep into the cosmos. It will reach back to a redshift of approximately 2.5, which is when the universe was only about 2 to 3 billion years old.
And what exactly is APN predicting that the HLTDS will find?
APN predicts that Roman will lock down the evolutionary parameters of the thawing quintessence with unprecedented statistical precision, reducing the variance to less than 1% for the primary intercept. Crucially, APN dictates that Roman will emphatically confirm the DTI-DR2 findings. It predicts that Roman will elevate that 3 to 4 sigma hint of a thawing dark energy into an irrefutable 5 sigma rigor. It will definitively, undeniably prove that dark energy is not a static constant, but a dynamic, growing force accelerating exactly in tandem with a cosmic history of quantum collapse.
So the falsifiability is absolute. If Roman takes this massive survey and finds that the standard model was right all along, that dark energy is just a flat, boring constant, and the DSI data was just a calibration error, then APN is dead in the water.
Yes. Is fully falsifiable.
Right.
But if Roman confirms the thaw with 5 sigma confidence, the cosmological constant is dead and lambda CDM is irreparably broken.
And what about the second survey, the test for the dark matter side of the equation?
That will be accomplished through the High Latitude Wide Area Survey, or HLS.
Yeah.
This is a truly monumental 520-day observational campaign. Roman will map over 5,000 square degrees of the extragalactic sky, a massive portion of the observable universe, and will map the invisible substructures of hundreds of billions of galaxies using a technique called weak gravitational lensing.
Weak lensing is different from the extreme Einstein cross we talked about earlier. Instead of looking for severe, dramatic bending of light, weak lensing looks at the tiny statistical distortions in the shapes of millions of background galaxies. By measuring how those millions of shapes are subtly warped by gravity, computers can build a highly accurate topographical map of where the invisible dark matter is located across the entire sky.
It is building the highest resolution topographical map of the dark web ever attempted in human history, and Martelloni's equation of historical inertial coupling will be overlaid directly onto this map.
This is the ultimate showdown. If the dark matter measured by Roman behaves like standard WIMP particles, drifting smoothly, rounding out halos, acting independently of the baryonic friction of stars, then APN's localized injection theory fails. Standard model physicists will declare victory, patch up their models, and move on.
But if APN is correct, the outcome will be revolutionary. If Martelloni's framework is accurate, the gravitational vectors and mass densities measured by Roman will perfectly, mathematically mirror the asymmetrical history of atomic fusions that occurred in those structures over eons.
The lumpy, heterogeneous dark matter will map exactly to the ancient stellar burst rates recorded by the baryonic decoherence index.
It will prove an inescapable causal determinism in the dark sector. The shape of the dark matter will unequivocally prove it was born from the stars.
It is incredibly exciting to be on the bleeding edge of science like this. We are theorizing about something that will take 50 years and a new particle collider the size of Jupiter to prove. The instrument to test this is built. It is launching imminently. In the next few years, we will know for certain if the universe is made of invisible phantom particles or if it is actively shaped by the gravitational memory of quantum choices.
It represents a potential triumph of stochastic quantum gravity. Just as the Higgs mechanism was mathematically predicted under the principles of gauge symmetry 4 decades before the CERN colliders actually detected the particle, Martelloni has built the stabilizing ontological sink necessary to encrypt the information injected by the universal wave function. He has provided the exact mathematical target. We simply need Roman to take the picture.
So, to step back and recap the massive journey we've been on today, we started with the foundational assumptions of the lambda CDM model. We looked at the JWST anomalies, where the impossible maturity of galaxies at redshift 13 broke the slow bottom-up assembly of cold dark matter. We looked at the Hubble Tension, where the modern expansion of the universe is outrunning the static cosmological constant.
And we explored how the architecture of null potentiality resolves these crises by redefining the dark sector entirely. We move from a universe of inert invisible dust to a dynamic universe where every single collapsed quantum wave injects topological memory into a higher 10th dimensional Calabi-Yau manifold.
Right.
We saw how the winding modes of string theory create local elastic tension, giving us the gravity of dark matter, while simultaneously exerting global outward pressure, giving us the accelerating push of dark energy.
We saw the causal inversion of the early cosmos, where hypermassive population third stars acted as decoherence engines, birthing the very dark matter halos that hold their galaxies together and totally solving the JWST timeline. We saw the localized, lumpy, ghost-like dark matter spikes of the Hurst 3 Einstein cross, acting as a spatial fossil of ancient stellar activity. And we saw the thawing quintessence of the DSI data, proving that expansion is tied directly to cosmic history.
It is a breathtakingly cohesive framework. It absorbs every major modern cosmological anomaly without invoking capricious extra degrees of freedom, phantom fields, or fine-tuned parameters. It simply requires us to enforce the laws of thermodynamic conservation onto the quantum wave function.
It is brilliant. And as we wrap up this depth dive into Alejandro Cariatti Martelloni's work, I want to leave you, the listener, with a final, really provocative thought, an extrapolation drawn directly from the philosophical implications of Martelloni's text.
If the architecture of null potentiality is correct, and if it is definitively proven by the Roman telescope in the coming years, it means the universe is entirely different from what we thought. It is not a random, sterile scatter of hydrogen gas and invisible particles. The dark web of the cosmos, the immense gravitational scaffolding that holds the galaxies in place, is actually a silent, multidimensional hypertextual library.
A library.
Yes, because every single microscopic choice, every thermal interaction, every radioactive decay, and every photon scattering that has ever occurred since the dawn of time is permanently recorded. The unchosen reality didn't just vanish. It is locked away as a geometrical scar in the dark matter. The shape of the universe is the literal, physical, heavy archive of everything that almost happened but didn't.
So tonight, I want you to go outside and look up at the night sky. Look at the stars, but more importantly, look at the empty black space between them. Because if APN is right, that space isn't empty at all. It is the massive, heavy archive of unchosen futures. And makes you wonder every time you make a choice, every time the atoms in your own brain undergo quantum decoherence and force the universe to snap into a single reality, what does your own quantum footprint look like in those hidden extra dimensions?
The standard model might be cracking, but what is rushing in to replace it is infinitely more profound.
We'll leave you to ponder that in the dark. Until next time.